Okay, Algebra 1 students, in this video today we are going to be learning how to solve linear inequality systems. Okay, now listen carefully. Remember, we've been dealing with linear systems, right? That have been made up of equations. Do you see the difference? Today we're studying systems that are made up of inequalities, linear inequalities. So far, all of the systems that we have studied have been linear, just like this, but they've been equations. Now we are switching to systems that are made up of linear inequalities, not equations. Please understand the difference. For example, in the past, you were solving stuff like this. Okay, now we're going to have inequality symbols instead of equal signs. Okay, so that's the difference. Your heading for today is Solving Linear Inequality Systems, Lesson 7.6. Please copy this in your notes and be sure and include today's date. Alright, Solving Linear Inequality Systems, Lesson 7.6, and be sure and include today's date. Let me start by saying that some people or some teachers would call this lesson graphing linear inequality systems. And you know what? That's fine. They would call it this because you know what? That's exactly what we're going to do today in this video. We're going to graph linear inequality systems. So you're probably asking yourself, Mr. Earhart, why did you call it solving linear inequality systems? Well, let me explain why I do that, okay? When you go to solve a linear inequality system, the only way to solve it, are you listening? The only way to solve it is to get a picture of it. In other words, you cannot give me a numerical answer like you can with a linear system that's made up of equations. Okay? Remember when you solved systems with equations, you would get out answers like this. 5 comma negative 3 or something like that, okay? When you're solving linear inequality systems, you're not going to get out nice pretty answers like this. The only way to solve these is to get a picture or a graph of the system. So why do I not call it graphing linear inequality systems? Because here's why. I'll tell you why. I want you to thoroughly understand that you are solving these. Okay? If I just told you we were graphing them, excuse me please, if I just told you we were graphing them, then you would think that we were graphing them. We're not. We're solving them by using what method? Graphing. Okay? So that's why I call it solving linear inequality systems. I want you to understand that yes, we are going to graph them, but in graphing them, we are actually solving them, and you'll understand this later as I show this to you, okay? So, let's jump right into this and start solving some of these problems. We're going to do one, two, three problems, and we'll be finished, okay? Please copy this first one in your notes if you would. Please copy this in your notes, and let's solve this. Now, first of all, notice most of the system, actually all of the systems so far we have looked at this year have had how many equations? 2. So notice right away the inequality systems might have 3, they might have 4, they might have 2, they might have 5 or 6, okay? So notice that. Also notice everything that we are solving today, they're all going to be inequalities, not equal signs, okay? So understand that. Okay, if I move too fast, just pause the video. So here's how we're going to solve this. What we're going to do, I'm not going to give you steps or anything, but what we're going to do is we're going to graph each linear inequality, okay? And then we're going to look for the area or the region that they all agree, and that's going to be your answer. And I know that sounds a little confusing, but if you'll bear with me, I will show you how to do this, okay? So in your notes, if you've not copied down this problem yet, please copy this problem down, and also in your notes, you're going to have to write down a coordinate plane. second, okay? Notice it's a single variable inequality. We have one letter. Second of all, it's a y, which means I'm going to have a horizontal line. So I'm going to graph my first line here, or my first inequality in green. So I'll put a little green asterisk here, and here we go. I'm going to go through 2. Y is less than or equal to 2, so I'm going to draw a vertical line, or excuse me, a horizontal line going through 2. Now would it be dotted or would it be solid? Well, it's solid because of the equal sign here, okay? And it's y is less than. Now you're used to going like this. Don't do that. Don't do that. Instead, just put arrows showing which way you're supposed to shade. We'll come back to that later, okay? Alright, let's move on to inequality number 2. We're going to sketch this one in black, so we'll put a little black asterisk here. Now, notice here I have x all by itself. Put an equal sign there just for a second so I can see it a little better. X equals -1, so I go to -1 on the x-axis right there, and I'm going to draw a vertical line, okay? Would it be dotted or solid? Well, I've got an equal sign here. It would be solid. And so here we go. Not the best vertical line you've ever seen in your life, but it's good enough. Now, it says x is greater than. X is greater than -1, so we would normally shade to the right, but instead of shading to the right, we're just going to put some arrows on here, okay? Now, the last inequality, we're going to do that in blue, and I'm going to go ahead and put an equal sign here just to help us. Now notice y is all by itself, so it's kind of fast to use the slope-intercept method, but to be honest with you, I'm going to do something else. I'm just going to quickly put in 2 x values and get out 2 y values. That's faster to me. Put a 0 in for x, you get out -2. Put a 1 in for x and you get out -1. So my ordered pairs are 0, -2, and 1, -1. There we go. So connect those 2 points and you'll have your dotted line. Now in the past I've taught you to get 3 ordered pairs, like your table of values, to get 3. But we've done so many of these now, I feel totally comfortable just getting 2 points. Okay, we're doing pretty good here. Now, notice here we do not have an equal sign. Do you see that? So we're going to have to put a dotted line. I hope you're remembering all of this, guys. We learned this some weeks back about how to graph inequalities. Okay, so if you remember that, you should be fine. The only difference is now we're putting all of them on the same coordinate plane. That's the only difference. Okay, now, when you have just one letter like here, it's easy to know where to shade. When you have one variable like we did here, it's easy to know where to shade. But here, when we have 2 variables, we have to test the point to know where to shade. My favorite point to test is 0, 0. 0, 0. Alright? So I'm going to put a 0 in for y, a 0 in for x. 0 minus 2 is -2. 0 is greater than -2. 0 is greater than -2. Is that true or false? Well, that's true. So we're going to shade toward 0, 0. So this blue line is shaded this way. Now the hard part is done. Now we have to simply decide where we're going to shade. Well, we know the green line says to stay all the way below the green line, right? So we know that. However, the black line said to stay to the right of the black line. So as I shade below the green line, I got to remember to stay to the right of the black line, okay? But hold on, the blue line's saying something too. The blue line is saying to shade above it. So, the green line is saying to shade down. The black line is saying to shade to the right. And the blue line is saying to shade up. So the only area they agree in is right here. This area right here. Alright? And so there we go. I think you're seeing now, students, why I said you cannot really have a numerical answer for these. You solved this. You now know the answer. But the answer is a picture, it's not numbers. Any ordered pair that falls in this shaded region is a solution to this inequality system. Also, because your green line is solid, any point that falls on the green line is part of your solution. because it's solid. Did you get that? Any point that falls on the black line is part of your solution because the black line is solid. However, any point that falls on the blue line is not part of your solution because the blue line is dotted. And so if it's dotted, that's not part of your solution set. Alright? And that's it. Okay, guys, I hope that makes sense. Let's try a couple more of these. Okay, now students, before we move on to this problem here, I forgot to tell you back here, this is called a bounded region, and I would definitely make notes of that. Make a note of that in your notes, okay? It's called a bounded region because you have boundaries on every side here, here, and here. Now you might be saying, Mr. Earhart, what does an unbounded region look like? Well, we're going to cover that in a little bit here, okay? But understand, this is called a bounded region because you have a boundary on every side, okay? Alright, moving on to number 2 here. Okay, please copy this in your notes. Let's jump right into this, alright? Here we go. Okay, guys, I think I'm going to pull this up here real quick to make this a little easier. There we go. Okay, so in your notes, please copy down this problem. Please draw a coordinate plane. You'll probably have to go ahead and pause the video and do that. I'm going to go ahead and move on, okay? Alright, my first problem here, I'm going to graph this in black. X is greater than 0. Now, that's just a single variable. It should be easy. It's like having x equals 0. So we put a point on the x-axis and we draw a vertical line. I want to make it a little darker since it's falling right on top of the y-axis. So there we go. And what does it say? X is greater than 0. So I'm going to draw arrows to the right like this. Okay, now, notice it's equal to, and that's why it's a solid line. Alright, let's go ahead and take a look at the second inequality. I'm going to graph that in red. And so we have y is greater than 0. Alright, so y equals 0. So we're going to put a point at 0 and draw a vertical or a horizontal line, going across here. There we go. And there we go. Alright. Now it's solid because we have an equal sign here. Okay. And y is greater than 0. That means I'm going to go upward. Like this. Okay, so far I know this. I know so far my entire graph has to take place in this quadrant over here, right? Because I can't go over here to the left. That's off limits. And I can't go below the red line. So kind of as you go along and put each line up here, you can kind of slowly start minimizing what areas of the graph you're dealing with so you know for sure there'll be no answer over here or here or here. So everything's going to be up in this region over here. Alright. We'll graph the next inequality in green. Y is greater than or equal to 2. So I'm going to go ahead and write y equals 2. Go to the y-intercept at 2 and put a vertical line. Okay? Vertical line going through there will be solid because of the equal sign right here. Alright? So there we go. Y is greater than 2. So I know I'm going to go upward. So now I know everything's got to be above the green and the red line. So up here and to the right of the black line. So everything now is going to be up in here somewhere above the green line. Okay? Alright, let's continue on. Now, let's graph this last inequality using blue. And again, I have y all by itself, which makes it nice. And I'm going to quickly put in 2 x values for x and get out 2 y values. Not because my denominator's 2. I'm going to use numbers in increments of 2 because that way I won't get out a fraction. Like I'm going to use 2 for x and 4 for x because when you take 2 times 1/2, you get out a whole number. When you take 4 times 1/2, you get out a whole number. So where the x is right here, I'm going to put a 2. Negative 1/2 times 2 is negative 1. Negative 1 plus 3 is a positive 2. I'm going to put a 4 in for x. Negative 1/2 times 4 is negative 2. Negative 2 plus 3 is 1. Alright, there. And let's do one more point just to check our work to make sure everything's right. Put a 6 in for x. Negative 1 half times 6 is negative 3. And negative 3 plus 3 is 0. So I've got a point at 2, 2. I've got a point at 4, 1. And I've got a point at, and that can't be right, my fault, 4, 1. And then 6, 0. There we go. We do have an equal sign here, so it will be a solid line. So here we go. Not a perfect line, but it's definitely good enough. And there we go. Now, we've got to decide where we're going to shade, either above the line or below the line, the blue line. So here we go. Notice how it was really easy to know where to shade here, here, and here, because all of those had what? One variable. However, the last problem that we're looking at, or the last inequality we're looking at, has two variables, a y and an x. So we're going to have to test our favorite point, 0, 0. So y is less than or equal to negative 1 half x plus 3. Put a 0 here. Put a 0 here. And what do we have? 0 is less than negative 1 half times 0, 0, 0 plus 3 is 3. 0 is less than 3. That's true. That's true. 0 is less than 3. So we're going to shade towards 0, 0. So let's review. We know everything's going to be over here in this region. It's above the green, above the red, but it's got to be below the blue. So green is saying above, black saying to the right, blue saying down. Looks like we have another bounded region. And there it is right there. That's my bounded region. Now this time all of my lines are solid. So any point that lies on this line here is part of the solution. Any point that lies on this segment here is part of the solution. And any point that lies here on this segment is part of the solution, plus anything inside the triangle here that's shaded in. Any point that falls in there is part of the solution. So we have solved this by using a picture, and there's your answer right there. We solved this one, and here was the answer right here. Notice once again we have a what? We have a bounded region, and you need to understand that, okay? A bounded region. Alright, let's try one more. We're officially done. One more. Alright, here we go. Now, both of these have two variables. Understand that, okay? I'm going to start with the first. I'm going to rewrite it with an equal sign. 2x plus y equals negative 4. Now, I'm not going to spend a lot of time on this. By now, you guys should know when you have an x and then a y and then an equal sign and then a whole number, we can use the double intercept method as long as this number right here is not 0. Listen to me, guys. If it's a 0, you cannot use the double intercept method. You can't. It won't work, okay? But we don't have a 0 here, so we're fine. So where the x is, I'm going to substitute a 0. 2 times 0 is 0. 0 plus y is y. Y equals negative 4. So my y-intercept is negative 4. Now let's put a 0 in for y and get out the x-intercept. So I have 2x plus 0 equals negative 4. 2x plus 0 is 2x. Divide both sides by 2 and x equals negative 2. Alright, so we'll come over here. Put a point at negative 2. I do have an equal sign here, so it will be a solid line. Let's go ahead and draw our solid line here real quick. Shade, we have to test our favorite point, 0, 0. As long as 0, 0 does not fall on this line, and it doesn't, so we're good. So where the x is, I'm going to put a 0. Where the y is, I'm going to put a 0. 2 times 0 is 0, 0 plus 0 is 0, 0 is larger than negative 4. That's true. 0 is larger than negative 4, so we're once again I have x then y then equal sign that whole number. So where the x is, I'm going to put a 0. 0 minus 2y is negative 2y. Divide both sides by negative 2 and y equals a negative 2. So there's my green point, or excuse me, my y-intercept. Now I'm going to put 0 in for y. 2 times 0 is 0. X minus 0 is x. X equals 4. So there we go. Now this will be a dotted line because there's no equal sign here. Please don't forget to check that. Okay, that's one of the most common mistakes where students forget to see whether they have a dotted or a solid line. Alright. Please remember to do that. Alright, now once again we have a double variable inequality. So we're going to test 0, 0. Alright. So where the x is I put a 0, where the y is I put a 0. 2 times 0 is 0, 0 minus 0 is 0, 0 is less than 4. No, that's true, 0 is less than 4, so 0, 0 works. So we're going to shade towards 0, 0. So do you see what we have? We have an unbounded region. We have to shade to the right of the red line, but we have to stay above the green line. Alright? So this unbounded region goes on and on and on. There's no stopping it, okay? It's going to continue on and on. And that's all you have to write or draw on a test or a quiz, okay? And there we go. That's it. So we did solve this inequality system. We solved it. We solved it by using a picture. Every ordered pair that falls in this area, shaded area, is part of your answer set, plus any points that lie on this line from here down to here, because that's a solid line. Any points that fall on this dotted line right here from here to here are not part of the solution set because they fall on a dotted line. Okay? And that's it. Students, I really hope this video has been a help to you. These are not difficult problems. This is just basically taking what we've learned in the past and putting them together on one coordinate plane, okay? But we are learning how to solve linear inequality systems. When you solve these, you will always get a picture or a graph for the answer. Contact me if you have any